Hello students, today we are going to study household circuits. Basically this chapter belongs to current electricity. It is a part of current electricity. It has been mentioned under a separate chapter of current electricity. So let's learn some basics about power transmission. Initially, electricity is generated at the thermal or hydroelectric power stations. Okay, so in power stations, what happens is mechanical energy is converted into electrical energy using generators. These generators basically they work on the principle of dynamo and produce large amount of AC voltage. Now, why we should not use DC voltage instead of AC voltage? See, uh, the reason is why we produce AC voltage than DC voltage is that its magnitude can easily varied with the help of transformers. We can use step up or step down transformers and we can easily change the magnitude. On the other hand, we cannot vary the voltage of DC voltage as it is fixed. Hence, power stations have generated uh, power stations have generators that produce AC voltage. Now, this electricity is transmitted to power grid system. The grid consists of towers to which have high tension base conductors. Now, this electricity from power station is supplied to the power stations which are nearby you, that is to the substations. Next. So, let's study how this power is distributed to our house. There are three ways to distribute this power to a house from city substation. First one, we can transfer this power through overhead cables. Second, we can transfer this power through a cable on poles. And third, we can transfer the power through an underground cable. This underground cable is very common and nowadays it is being used. Now these cables will be having three wires. Okay, three main wires. One is live wire, another one is neutral wire, and the third one is earth wire. Live wire is represented by alphabet L and it has red insulation cover. Neutral wire is represented by alphabet N and it has black insulation cover. Earthing wire is represented by alphabet E and it has green insulation cover on it. So, what does live wire, neutral wire, and earth wire do? Now, what is the purpose of using this live wire? Live wire carries current from the current source to the distribution board. It is said that neutral wire returns the current back to the source and it forms a complete circuit. And then comes earthing wire. Earthing wire ensures that any leakage of current goes to the earth only and then it is safe from any kind of shock. Directly, the earthing wire supplies the excess of current to the earth and we become safe. If any leakage, then it goes in the earth. So this is about live wire, neutral wire and earth wire. Next, we'll study about electric fuse. Okay. So let's study about some essential components of household wiring system. So fuse is a safety device. We know that fuse is a safety device which is connected in the live wire after the kilowatt hour meter and before the main circuit. When current in the circuit exceeds the load limits, the fuse protects and circuit by blowing off. Okay, when current in the circuit exceeds the load limit, fuse protects the circuit by blowing off. Also, fuse is connected with each electrical appliance to safeguard it from the flow of current in excess of its safe limit of current. Electric fuse is a piece of wire. It has two properties. Basically, you need to remember this and which are very important. The two properties are the fuse has low melting point and it has high resistance. A fuse wire permits flow of current through it only up to certain limit which is known as current rating. Beyond this rating, if the current flows, then the fuse wire will blow off. For example, if the current rating is 10 ampere, then the fuse does not allow current more than 10 ampere. If more than 10 ampere current passes through the fuse wire melts. If the current exceeds this limit, then temperature of fuse wire reaches the melting point and the wire melts so that the circuit gets broken. The rise in temperature of fuse wire, it is dependent on current rating and also the radius of the wire. The thickness of fuse wire depends on its current rating. Higher the current rating, thicker the wire. If the current rating is higher, thicker is the wire. And if the current rating is lower, thinner the wire. For example, fuse wire of current rating 1 ampere is of radius 0.2 mm. For example, while the fuse wire of current rating 8 ampere, it may be of 0.8 mm. It is not actually fixed. If current rating is more, then thickness will be more. If current rating is less, then thickness will be less. Next, study electric fuse in detail. A fuse is a short and thin piece of wire of uniform area of cross section and it has high resistance. Fuse wire is made up of material which is having low melting point so that it may easily melt due to overheating when current through it exceeds the prescribed limit. And generally the fuse wire is made up of an alloy of lead and tin. It is used as material of the wire because its melting point is low and specific resistance is more than that of copper and aluminium. A copper or aluminium wire is unsuitable for use as the fuse wire because they have high melting point. Moreover, the use of an ordinary copper or aluminum wire as a fuse must be avoided as it is very thick, so it will not melt even if the current exceeds its safe limit. So what is going to happen if we use a copper or aluminum wire? As they have high melting point, the wire will not melt and connection between the fuse wire will not be cut. So there may chance of getting excess of current in the system. So, in electric wiring for light and fan circuits, a thin fuse wire of low current rating is used because the line wire has current carrying capacity of 5 ampere. A thick fuse wire of high current rating 15 ampere is used for heavy current consuming appliances such as air conditioner, geyser, washing machine, etc. Because the line wire for such appliances has a current carrying capacity only of 15 ampere. Now, current rating of a fuse in a circuit is given by the total it is given by the ratio of total power of appliance in the circuit to the voltage of the supply. You should always remember that fuse is always connected in the live wire before the appliance. So next study why we connect fuse in live wire. Now we will understand why fuse is always connected in the live wire. You can see in the first diagram that this is an appliance there live wire and this is the appliance you can see and there is a live wire and there is a mains, okay, and there is a fuse. Now as there is fluctuation or any kind of short circuit or fault occurs, then fuse will break and no current will flow in the appliance. So now your appliance is safe. High voltage current is not flowing through the appliance, therefore the appliance is safe to use. This is the reason of connecting fuse in the live wire. Now let's understand what happens if we connect fuse in live wire. Let's understand. If we don't correct connect fuse in the live wire and instead if we current the fuse in neutral wire, what happens? You can see in the second diagram here that the appliance is directly connected in the live wire. The appliance is directly connected in the live wire. Now, as there is a fluctuation or any kind of short circuit occurs, directly the current flows through the appliance because there is no fuse to melt and to cut the connection, and still the current flows in the appliance. So high voltage current is flowing in the appliance and it is very dangerous to do that because the person may get fatal shock. This is the reason we don't use fuse in neutral wire. So let's study about working of electric fuse. Okay, so we know that fuse is made up of a material which is having low melting point. When current in the circuit exceeds the specific value due to any reason such as faulty connection, such as high voltage, such as short circuiting, the temperature of the fuse wire rises to the extent and it melts. As a result, what happens? There will be a gap produced and the circuit breaks. Now, current does not flow through the live wire and the appliance is safe. After removing the fault in the circuit, a new fuse wire of same current is connected in a holder to complete the circuit again. So nowadays, instead of fuse, miniature circuit breakers are being used. Miniature circuit breakers is used for each individual circuit. If due to some fault or heavy current flows in the line, the MCB falls down to switch off the current in very short time. After repairing the fault in the circuit, the MCB is then raised up. You might have seen these MCBs in your houses. Thus, the use of MCB is easier than fuse because MCBs avoid the inconvenience of connecting a new fuse and it is much safer due to its quick response. This is about MCB and electric fuse. Now let's study about switches. A switch is an on-off device for current in a circuit. Switch is a on-off device for current in a circuit, okay, or in an appliance, and it is connected in the live wire. Again, why we cannot use switch in the live wire? You can see in this diagram switch is connected in the live wire. When you switch off, switch is connected in the live wire. When you switch it off, bulb is not glowing, thus it is in off position. When you switch it on, the bulb starts to glow. See here. Now, if something happens to the appliance, easily we can switch it off and we can repair because current is not flowing through the appliance. In the first figure, you can see that the switch is in on position and live wire is connected to the bulb, and as the switch turns off, the connection between live wire and the appliance cuts. Therefore, there is no current flows through the bulb. In the second diagram in off position, you can see that when the current stops, there is no connection between live wire and bulb. Now again we can see why switch cannot be connected in the neutral wire. It is deceptive and dangerous to connect switch in the neutral wire. In the first figure you can see that switch is connected in the neutral wire in on position and it allows the current to flow in the bulb and the bulb glows. In the second position you can see that Even in the off position, no current passes through the bulb. Thus, the switch serves its purpose. But in the earlier figure, you can see that in off position, the current was not flowing to the bulb. But here in this second diagram, you can see that the appliance remain connected to the high potential. There is high current passing through the appliance to the live wire. This is the condition. It is not safe to carry out any repairs in the appliance because on touching the live wire in the appliance, the current will pass through the body of the person and the person may get fatal shock. Even in the off position, what is happening? Large amount of current is flowing to the bulb. So that is the reason we use switch in live wire. Next, what are the safety precautions we have to take while using a switch? A switch should never be touched with wet hands. If water reaches the live wire, what happens? It forms a conducting layer between hand and the live wire. So your hand, live wire, your hand, water and live wire. So there is a conducting layer. So what happens? Current passes to the hand through it and the person may get fatal shock. So never use switches using wet hands.